the derivative of that function x cubed plus px squared, that is 3x squared, 2px, that is correct. Letting this to be 0, yes, and we can make, actually we don't need to do it this way, meaning plugging the value 0, 0 of the origin to this equation, but we simply just need to assume that it is 0, the derivative is 0, which means 3x squared plus 2px is 0. We can make x the common factor, 3x plus 2p equals 0. And one solution here is definitely x is 0. The other solution is that 3x plus 2p is 0. So from the first here, x equals 0. From x equals 0, we can plug the value of x into the initial, the original equation, and therefore with x is 0, the y is also 0. So from this, we can conclude that the origin is one stationary point. So the origin is one stationary point. The next thing, and find the coordinates of other stationary point in terms of p. So other stationary point, we have to determine the value of x in terms of p from this equation. And you did it correctly, yes. X is minus of 2p over 3, minus 2p over 3, correct? It's just, I think you need to change the method, the writing, the step here, instead of like replacing 0, 0 into the equation of the derivative. Okay. The next question, find the nature of each stationary point. Y equal 2p over 3 cubed, okay, plus p, this one squared. And you're trying to simplify that,
Yes.
Minus ap cubed 27 plus 4p cubed over 9. Yeah, correct. So yeah, well done. So we completed the question A, question 1. Now the question 2, find the nature of each stationary point.
So I think that e to p is a positive constant.
Positive,
and,
yeah. Positive.
And 4 over 27 always greater than 0. I think that the 2p over 3 and 4p cubed over 27 is the maximum, and the 0, 0 is the minimum. I mean, like, only the y-axis matters.
I got the idea. Yeah, I got it. You're right. That is an acceptable explanation, Okay, you're right. That's one way. Yeah, this is the correct one. Solution. At 0, 0, it is the minimum. The second, okay, the method they do here is using the second derivative, which I will explain to you. Yeah, you already learned that using the second derivative to determine a stationary point is maximum or minimum, right? Other methods, okay, other methods here.
I know what they try to do. So they just differentiate that thing again. So they plug it in. If it's greater than 0, it's minimum. It's less than 0, it's maximum.
Exactly. And I told you about that once, in the previous lesson once. But of course, we need to practice many exercises to really master this topic, not just once, Okay. But here, some other method. Yeah, other method. They allow us to use other method, including clear demonstration of the side chain of the gradient, clear reference to the shape of the curve. Okay, so saying about the shape of the curve, which you already explained, is also acceptable. One way to answer that. I was talking about the direction of the change of the first derivative. Here at the maximum, the first derivative, the gradient of this tangent, is decreasing on the left for the x lower than the maximum, and then the derivative, the gradient decreases. Okay, so the change of this first derivative will help us to determine the maximum or minimum. Okay, for the minimum, it decreases here and then increase. The easiest way is to use the second derivative. and plug the value of the stationary point into the second derivative. If the second derivative is negative, that point, the stationary point, is maximum. And if the second derivative is positive, that point is minimum. Okay, and so please continue writing your answer on your notebook, and keep doing question 3. The set of the values of P for which this curve has no stationary points. Another curve, okay, this is another curve. No stationary point, meaning the first derivative has no zero value. There's no solution, no roots for the equation. The first derivative equals 0.
Set values of P which the curve has no stationary point. So it's either less than 0 or like larger than 0, right?
No, it's just the first derivative cannot be 0. Letting the equation, the first derivative equals 0, that equation has no solution. Let's solve that with the differentiation. Y different derivative is 3x squared.
Mấy cái curve mà nó không có stationary point là nó không có solution mà.
Okay. For the curve to have no stationary point, the equation y derivative equals 0 has no solution. Only if, when its discriminant delta is less than 0. Only if. Okay, that delta is equal to 2p all square minus 4 times of p multiplied with 3, meaning 12 times of p. So this is 4p squared minus 12p. It must be less than 0. And we can plot the graph of this derivative like this. Okay, and find the 2 points. It's this graph intersect with the x-axis, and the lower part of the graph is in between the 2 solutions, x1 and x2, meaning x must be between x1 and x2, so that this discriminant is less than 0. We can find x1, x2 very simply, making 4p the common factor. This is p minus 3, and it is 0 when p is 0 or p is 3. Okay, so between, so we can conclude this is like a draft. Okay, we do not write it in the solution. Okay, we only need to write the conclusion, which is p greater than 0 and less than 3. Okay, so let's plot this graph on a Desmos graphing calculator to see how it looks like with a value of p to be greater than 0, less than 3, for example 2, 2x squared, and p is 2x, 2x, okay, here. So this is a equation having no stationary point, a function, a graph having no stationary point. Let me adjust this thing like from -4 to 4 here. There is absolutely no point through which the tangent is horizontal.
Yes.
So